Hello, this is the Comms Optic Senior Design poster presentation. My name is Nathan Scantz, and in this video we will be discussing the different sections of our poster, which are the purpose of our project, the procedural steps involved in our design, an overview of our project, and the mechanical and chemical separation, and our resultant conclusions. Our project is finding sustainable alternatives for fiber optic cable disposal. Our industry supporter is CommScope. The purpose of this project is to identify options for the reuse, repurpose, or reallocation of CommScope's waste generated from the manufacturing of its fiber optic cables, as well as worn or old cable outside of CommScope. The work done by the team can be broken down into two sections: mechanical and chemical separation. The procedural steps involved in our design are production, testing, spooling, removing the outer jacket, taking up the central core, and recycling. Our machine is implemented when removing the outer jacket. Once the outer jacket is separated, the inner core can be taken up, and the outer jacket can be taken to a recycler.
For the mechanical separation, the device allows for the cutting of fiber optic cables using a continuous automated process. It uses two motors, one which feeds the cable in and the other which spins a saw which can cut through the outer jacket. The feeding motor is a VFD variable motor which allows for variable feed rates. The cutting motor also has a blade that can be easily removed and replaced as it gets worn down. For the chemical separation, since the mechanical side focused mostly on non-gel filled cables, the chemical separation attempted to break through this gel, using the chemicals shown on screen. However, based on the team's observations via the chemical experiment, none of the above chemicals would be recommended for dissolving the protective gel used by CommScope. Currently, the team recommends CommScope focus their efforts on non-gel filled cables. In terms of results, as shown on screen, the hertz of the machine for the variable feed rate was tested through various settings. 39.9 hertz was seen as the minimum required to get the depth of cut needed, which was approximately 1/8 of an inch. This successfully cut through the outer jacket without damaging the interior parts. These interior parts could then be extracted by hand and used for recycling purposes.